All right, now we're going to go ahead and use synthetic division for our previous example where we used long division. Now let's make sure that we understand there are limitations to synthetic division, that long division will work for any polynomial. That is to say if the degree on here is higher than the degree of this divisor. Synthetic generally only works for linear divisors, that is to say we have x plus or minus some constant. Generally the coefficient is or should be 1, however there's ways to bypass that. Okay? So we set up our problem similar to long division. We go ahead and write our, we call this the little house in elementary, but it's our vinculum, our division sign. And instead of putting all our dividend and all our divisor with the variables, we just put the coefficients. So the 4, the negative 15, the 11, and the negative 10. So the 4, the negative 15, the 11, and the negative 10. Now, same thing as before, they do stand for place values. So our dividends numerator has to be a polynomial where the degrees are in descending order, and if they do skip one, we would have to make sure that we put a 0 for that place value. Okay. Now, as far as our divisor, normally we would put x minus 3 outside here. But what we do is instead we go ahead and, or we can think about saying our divisor set it equal to 0. And if we solve for x, we go ahead and that's what we put out here. Okay. Now, in some textbooks, they do go ahead and leave that negative 3 out here. And some textbooks refer to as putting the additive inverse of what we have here. But we're going to go ahead and use that, and I'll explain the difference right now. The steps for synthetic division are drop down this 4, and we multiply 3 times 4, and we end up with 12. Now, here's where it becomes a little different than long division. We have negative 15 and 12. Over here, you can kind of see the similarity, negative 15, but here we had negative 12. But we do subtraction over here, but this time we're going to add our columns. So we end up with negative 3. Now again, the difference here, had we not used what we call the additive inverse or the opposite of this negative 3, then if we left it at negative 3, then we would end up with negative 12. We would just subtract these columns instead of adding them. All right, so let's just multiply again, reiterate our steps. 3 times negative 3 is negative 9. Add these two, you get positive 2. 3 times 2, you get 6. Add these, you get negative 4. Our last column is what gives us our remainder. Now again, we're only dealing with coefficients, so our answer here is just the coefficient for our answer. Now the important thing to understand is that we are dividing 4x cubed by a linear divisor, so that's going to go ahead and drop down our quotient 1 degree. So instead of saying I know over here we had set that it's a place value for x cubed, we kind of disregard that and just drop down 1 degree, 4x squared minus 3x, and then this is positive 2, so put plus 2. Same thing as we write our remainder over our divisor. Okay, so it's going to be plus negative 4 over, and again, very important that you do put the original divisor, x minus 3, not this divisor. This right here, again, is just a systematic approach of our solving our problem.